The greatest integer function is also a piecewise defined function, and it's most commonly referred to as a step function or the floor function, simply because it resembles steps or stairs. So recall a few things about a greatest integer function. First of all, as far as what you're allowed to plug in, the domain or the input values, you can plug in anything from negative infinity to positive infinity. The only restrictions is your output or your range. It can only be an integer. So I'm going to go ahead and put a number line on the bottom just to help you visualize it. So our first point we plug in is a negative 1.75, and that's going to be between negative 2 and negative 1, closest to negative 2. Now in terms of rounding, we're so used to rounding up, but you have to remember when you are dealing with greatest integer functions, you must round down. So you're always rounding to the left, always to the left. So the closest integer to the left of that point would be negative 2. So my output is negative 2. If I plug in a negative 1.5, again, the closest to the left integer would be negative 2. Negative 1 is already an integer, so the output is going to be the same, a negative 1. A negative 0.75. Closest to the left, that's an integer, would be negative 1. Negative 0.25, even though it's closest to 0, we always round to the left, so the closest integer would be negative 1. 0 is already an integer, so that's going to be your output. 0.5, that's like a half. And even though it's in between, we always round to the left, so the closest integer would be 0. 1 is already an integer, so the output is going to be 1. 1.75 is closest to 2, but we always round to the left, so the closest integer would be 1. Last one, 2.9, and even though that's almost 3, we still have to be careful and round to the left, so the closest integer left would be 2. And this is what our graph looks like once we plot all of our points.